Hi everyone! Today we're going to study the parabola with vertex at the origin and opens upward. First, let us define parabola. A parabola is a set of all points in a plane equidistant from a fixed point and fixed line in that plane. The fixed point is called the focus of the parabola, and the fixed line is called the directrix. Let us draw a parabola that opens upward. First, let us draw a line and a point. The point is the focus and the line is the directrix, and this is a horizontal line. Let us find points that satisfy the condition of parabola. The first point that we can think of is the point between the focus and the directrix. And let us find more points. Here are two more points. Another points that we can think of are here. And then let us connect these points with a smooth curve. And this is now our parabola. And we put one point of the parabola in the origin. This is now a parabola with vertex at origin and opens upward. We let A be the distance from the vertex and focus. By the way, this point here is the vertex and this is our focus. And the distance is A. The coordinates of the focus is 0, A. And the directrix, the equation is y equals negative A. The line perpendicular to directrix and passing to focus is called axis. This is the axis. In this example, the axis here is the y-axis itself. So the equation of the axis is x equals 0. The intersection of the parabola and the axis is called vertex. So again, this is our vertex. The chord drawn perpendicular to axis and passing through focus is called latus rectum. This is the line segment that we called latus rectum. Let us now derive the formula. Let us pick one point of the parabola, let's say this point, and we put this as point P with coordinates xy. And then let us consider the distance from this moving point to the focus, and that is a fixed point. We denote this as d sub 1. And then we take the distance from the moving point away from the directrix. We denote this as d sub 2. By definition of parabola, we say that d sub 1 equals d sub 2. Take note, d sub 1 is distance between 2 points. So we use the formula for distance between 2 points. So we have now d sub 1 equals the big square root of x minus 0 is quantity squared plus y minus a. This is also squared equals the d sub 2, and this is equal to y plus a. Let us square both sides to simplify further. So the left side becomes x squared You see here the x minus 0 is simply x, and then this square of y minus a we simply copied here. And this is equal to the square of the right side, and that is y plus a, and it is with power 2. Simplifying further, let us expand the squares. On the left side, we have this x squared. We'll just copy. And the square of y minus a now becomes y squared minus 2ay plus a squared equals, the right side is the square of y plus a. So we have y squared plus 2ay plus a squared. We can see here that there is y squared in both sides, so we can cancel that. Also, there is a squared here and here that we can cancel also. Simplifying now, this negative 2ay we will transpose on the right. So from negative, it becomes positive. So the left side now is x squared equals, the right side is 2ay plus 2ay. Combining the right side terms, we have now 4ay. It means to say, we have now the equation of parabola with vertex at origin and opens upward. Let us now substitute y equals a to get the coordinates of endpoints of latus rectum. Again, this is our latus rectum. So we have now x squared equals 4ay now becomes 4a times a. Multiplying this a and a, we have a square. To simplify this equation, let us take the square root of both sides. So we have the square root of x squared equals the square root of 4a squared. So the value of x equals plus or minus 2a. It means to say, the endpoints of latus rectum are the points 2a, a, this is the point, and negative 2a, a, that is the point. Looking at this graph, we can see that the length of latus rectum equals 4a. Take note that this 4a is the coefficient of y in the equation of parabola with vertex at origin and opens upward. Let us see this example. Sketch and discuss x squared equals 16y. For our solution, we can see that this given equation conforms with our equation of parabola x squared equals 4ay. So it means this is a parabola with vertex at origin 0, 0 and opens upward. Taking now that value 16, because that is equal to 4a, first we know that this is the length of latus rectum. And then let us solve for a. Dividing this equation by 4, because that is the coefficient of a, we will get the value of a equals 4. From here, we can say that the focus has coordinates 0, 4, while the directrix is aligned with equation y equals negative 4. We know that the axis is the y-axis itself, and the equation is x equals 0. Using these initial references, we can now draw the parabola. This is the parabola. X squared equals 16y. This is the vertex at the origin, the focus at the point 04. This is our line. This is the directrix. Y equals -4. And then we can now get the endpoints of latus rectum using this formula, plus or minus 2a, a. So the points are 8, 4, this is the point, and -8, 4, this is the point. This is our final answer. I hope you learned something from this video. See you again next time.